Okay, it seems that we're live. And Andre, thank you so much for joining us to deliver this live demo session of the Solana VS Code extension that we released last week. Really great to have you here. For the people joining us, just a bit of context about our presenter. Andre is team lead of the Solana team here at Taki and a lead auditor, and he's also the lead lecturer of the School of Solana. Through a total of 8 seasons, he has taught over 7,000 people, and there are thousands of graduates already building various projects on the Solana ecosystem. So, without taking any more of the time, I would like to hand over to Andre, who is going to go through a brief presentation and then dive into a hands-on demo of the Solana VS Code extension. Andre, over to you.
Yeah, sure. Welcome everyone. Hopefully you can hear me. Before we start, I would like to say that or apologize for my voice because for past few days I feel slightly sick. I cough sometimes. I need to sneeze sometimes. So maybe it will happen also during the session during the presentation. I would just to say sorry, and I will sometimes maybe need to mute myself. But yeah, I have water prepared, I have tea, I have coffee, so hopefully everything will go all right. Thanks, Martin, for the really nice introduction. And yeah, in this presentation and then in the demo, we will discuss the first security-oriented VS Code and also cursor-based extension for Solana. Martin, I would say, already said everything, so maybe I will repeat him. But yeah, I'm the lead auditor at EKI of the Solana smart contracts and only Solana smart contracts. Uh, I was participating in one of the earliest School of Solanas or one of those earliest seasons of the School of Solana. And right now I'm the lecturer at the School of Solana. Why we actually decided to create the extension for the VS Code and for the cursor. You can see the video. This video was already shared on the socials, so maybe some of you already seen this video. So I think it is not necessary to watch it right now. So I would like to continue to the next slide. And there are two main reasons why we decided to basically create this type of extension. The first thing is lack of tooling. If you type Solana into the extension finder in the cursor, also VS Code, you will see that there are not that much extensions for Solana, even security-based extensions. I know that there are a bunch of CLI tools for the static analysis, but there is none as a VS Code extension. Everything is as a CLI tool. So what it does is that you write your smart contract and then you need to run the CLI tool. On the other hand, the VS Code extension is in this case much better from my point of view, because when you write the smart contract, the source code, just press save and it immediately looks for the detections. The second reason is that we wanted to fill the gap. As I said, I was participating in one of the earliest cohorts of the School of Solana. I would say I have a bunch of audits already behind me. So I would like to say that I have some kind of experience, and based on this experience, we noticed that there is a gap between basically developers and what they expect will be the results of the audit and what the actual results are. Uh, there are two branches, let's say. The first branch is that the devs basically do not test extensively the smart contracts, and then we find 20, 30, 40 issues in the smart contract. The second branch is that developers think and they are over confident that their smart contract are secure and we will not find anything. So that's why we wanted to actually fill the gap, because we noticed that in 70-80% of audits there are a lot of informational severity issues, a lot of warnings, a lot of lows, even mediums, that can be really easily prevented, because Even some small changes to the source code can create denial of services, etc. So we wanted to fill this kind of gap and add some tool to the ecosystem, because we already added Trident, but it requires some kind of manual intervention, let's say, when you need to write tests. But in this case, we wrote the detectors. You don't need to do basically anything, just install the extension, and all of the warnings and the issues that our detectors found will be immediately shown to you. So that's why we wanted to fill the gap. For those who don't know what the extension actually is, there might be some of you. So we aim to fill the gap of these two core principles. It is really minimalistic and simple. The first thing is code coverage for the Trident fuzzer, and the second thing is the static analysis that can be directly in the ID, basically in the text editor you use. That said, I would like to continue to the hands-on example. So now I can show you how it works. So let me open the cursor. Okay.
Thank you, Andre, so much. And while you're opening cursor, just to remind our audience that any and all questions are welcome. You can drop them as a reply to the pinned post on the Trident Solana account. And now we're going to dive in the actual demo of the extension. Andre, back to you.
Thanks, Martin, for filling the gap. And yeah, so if you can see, I'm in the cursor. I will describe the protocol later, or the project later, which is here in the example. But firstly, let's install the Solana extension. So just click on this arrow, extensions, and type Solana, right? You can see I do not have it installed yet because I want to show you everything from scratch. So I just installed the extension. Everything is installed. It was pretty fast. We can open the settings. And as I said, everything is minimalistic, so there are not a lot of settings that you can, for now, change. But what might be interesting is this coverage server port. Leave it as this default value, but you will see then later in the trident.toml, we will set the server port. It should be definitely all right if you leave it as a default, but you may find it useful later if you fuzz multiple programs, etc. All right, so let me close it and let's go back to the protocol. So what the project is? The project is example from the Trident. It is from the Trident benchmark, and it is Maze 0. So this is not anything like synthetical for just this space. This is a real example that is already in the Trident for a couple of months. So you can go directly right now to the Trident GitHub, clone the Trident, and try the example by yourself. This example is called Trident benchmark. We are in the Maze 0, and what the Maze actually does, this project is taken, I think, from the Ethereum ecosystem, and it was benchmarking example for a number of found issues in the Trident. We were using it for a couple of months already. So this is just a brief overview of the project, of the program. I don't think I need to go into more details. Maybe, all right, there are a bunch of instructions. So initialize, move north, move south, move east, and move west. What's the principle of fuzzing here is that we want to move to some new coordinates, and we want to fuzz also to which direction we are moving. So we are moving to the west, we are moving to the east, we are moving to the south, and we are moving to the north. And by the fuzzer, we want to navigate in the maze. It is not the main initiative to create Trident tests right now. So the Trident tests are already created. As I said, everything is already on the GitHub, so you can have a look even right now. So let's now continue to the setup, and then I will run the coverage and you will see it in the real time. So first thing that you need to do is to go to the Trident Tomo and add these fields. So first field you actually enable the fast coverage. Maybe I can increase the size so you can see it better. You need to enable the fast coverage. The second thing is the server port I was describing earlier in the settings. I think it is completely all right if you leave the default value here and also in the extension. Loop count, that's 5, that's the default. Format JSON also default. And the attach extension, if you want to see the coverage in the real time, use true. There is also different option. It is described in the documentation. There is also second option that you can use. And in the second option, the coverage is not displayed in real time, but it is collected during the fuzzing. If you run the fuzzing for 5-10 hours, then after the 5 hours long run, the coverage report is generated, and then you can see the final coverage. In this case, we are going to focus on real-time updates of the coverage. So this is the first requirement, and the second small requirement is that within the fast test, in the test fast.rs, in the new function, you need to deploy the program through the entry point, not through the binary. There are two options, everything described in the Trident documentation. There are two options how to deploy smart contract through the binary or through the entry point. In this case, you need to deploy through the entry point in order for Trident to actually be able to collect the coverage. So that's everything from the requirements. What we can do right now is that I can open the terminal. I'm currently in the work in the root of the project. So let me navigate to the Trident tests and let me run the fuzzing session. And before that, let me clear the terminal. Okay, you can see the fuzzing session is running. I set it for 1 million of transactions. So there are a bunch of transactions. We have a bunch of time to comment on this. So you can already see there are some kind of updates here. The first update is that you can see already numbers. So there is 46%, some kind of battery indicator. And the second thing that you can see is the numbers within the smart contract. So the first thing that I described is the 36%. And this number actually shows you how much of the source code you actually went already through. So in perfect conditions, it should be 100%. But as you know, Anchor has a bunch of macros, a bunch of branches in those macros that will not be possible to actually visit by the fuzzer. So in this case, it is nearly impossible to achieve 100%. The second thing is that why it is not changing right now is that because this is slightly harder example. As I said, this example was used for benchmarking, so it is expected that we will run fuzzing on this example for tens of minutes, hours, not 2 minutes or 3 minutes. The second thing, which might be more appealing here, is that you can see already the numbers in the source code. So as I said, there are a few instructions in the program: initialize, move north, move south, etc. So let's start with the initialize. This number actually shows you how many times the initialize was executed. There are no if statements, no for loops, no branches in the instruction. So we have just this number, and if we get into the initialize, everything is executed correctly. The second option is that you can have branches in the instruction. So for example, this require. The require has two branches in principle. The first branch is that this condition is met, and the second branch is that the condition is not met. And here is where the coverage actually is really useful, because in this case, you can still see how many times the move north instruction was executed. So right now it is already almost 200 times. 200,000 of times, but you can already see how many times this error was actually returned. So if you know this error was returned already for approximately 20,000 of times, you can know that the remaining number of times we actually fulfilled this condition, and we were continuing deeper in the smart contract. Let's go to, for example, the step function, and in the step function, you can see that there are groups of conditions. As I said, this is really useful for benchmarking because uh, really good fuzzer will get through all of these conditions and find the bug that is hiding behind the conditions. And you can see right now with the trident, so far we reach just this first condition, but of course there are some different conditions. There are like complicated conditions. So in this case, you can see this if statement will never be true because p2 will always equal p2. So there are also some logical preconditions for the smart contract. However, you can see there is another group of conditions, and that's this thing. So you can see we are already going deeper and deeper, and at the end, after a few minutes, we will get to this panic. So yeah, I think this was an overview of the code coverage. The best principle here, or the best thing that's the most important, is that it does not need to be used on this benchmarking example, which is quite complicated, quite difficult, but it can be used on your smart contracts, where you can see which part of the smart contracts were actually tested, which parts were not tested, etc. All right, the fuzzing session already ended, so yeah. This is everything from the code coverage, and now let me change the window and I will show you different example of the static analysis.
Thank you very much, Andre. That was fascinating. Of course, just as a reminder to everyone on the call, two main features or two main functionalities to the extension. The one of them is the first testing first testing code coverage that Andre just showed, that requires integration with our solution Trident. And the other one is the static analysis detectors that Andre is going to show in a minute. So far, we have 9 available, covering some of the main and most prevalent issues that appear on Solana programs. As we work, as we improve, as we release the next versions of the extension, of course, we'll be adding more of them. And for that, your feedback is super helpful. So, any observations, feedback, even criticism, everything is welcome. Just drop us a message on X at Trident Solana. Back to you, Andre.
Definitely. Thanks, Martin, for adding this, because I noticed that Solana already created YouTube video for the VS Code extension, and we definitely appreciate the feedback. From our side, we are just currently working on improving everything. We have in backlog a lot of new detectors that we want to implement. We were starting with a more simpler one, but we definitely aim for detectors that can find criticals, highs, mediums, etc. And also we have different approaches that allows us to detect more complex issues. But yeah, the main reason is that yeah, I want to thank the Solana for the feedback. Definitely appreciate it. The feedback always helps us to improve, so that is really nice. Regarding the static analysis, what you can see right now is different project, and this is again not that important to completely understand what the protocol does, but you can see there is some kind of place bet instruction, resale market, withdraw, etc. You can guess that this might be some prediction market or something similar. What might be, on the other hand, more interesting is that you can already see, if you are familiar with the Rust analyzer and the Clippy, you can already see that there are a bunch of warnings and errors. And what is interesting is that these errors are not coming from the Clippy or from the Rust analyzer, but these are going from our static analysis code extension. So that's why it is really useful, because if you write the smart contract, you can immediately see the results of the detectors. So let's start with, for example, with the lib.rs file. So here is, for example, the first warning coming from our extension. We notice that sometimes developers forgot that the instructions need to be signed with by some kind of authority, and in that case there is no authorization. The smart contract then can update the data account, and there might happen some unauthorized update of the data. So our first detector, or one of them, basically looks if there is any signer in the context, and if there is no signer, have no signer field, consider adding a signer's info field to ensure proper authorization. That's just the warning. Of course, if you are skilled, if you know what you are doing and the instruction does not need signer, in that case, you can completely ignore the detections. The second thing which is here is that instruction parameter question has type byte basically, but handler function expects type string. So you may know the instruction parameter, the instruction macro. I think we were covering this also in the School of Solana. So you can basically, in the context, you can use instruction parameters that are passed to the instruction. In this case, you can see the question is expected as a string, but the user, the dev, is expecting it here as just 1 byte. And in that case, yeah, it can happen that you know what you are doing and you just want to take the first byte from the string. That might be completely all right. But in 99% of times, you would like to take the whole string. So this detector checks the type and also checks the order. So if you correctly deserialize it into string, then integer 64 signed and the vector. And I think that's everything from this file. Let's move to the vote. Here I would like to definitely talk about the false positives because you can see we have underlined this part. And this part says that unchecked arithmetic operation detected. If you have a look, you already know that this cannot overflow because it is 41 and it always will be 41 in total. So it will never overflow. And that's the false positive. What we don't want to show you is that our static analysis don't have false positives and we have 100% accuracy. I would say in almost 100% of times this is not possible, and definitely there will be always some false positives. But we definitely think it is much more better to have some false positives than don't have any detections. So in this case, yes, there will be false positive, but we are trying to reduce the false positives and only show the real issues. What is another warning here is that there is the init space not used, which is also available in the Anchor framework as a macro. So yeah, that might be useful. It is just a warning, so not mandatory. All right, let's move to the video. I was talking about the false positives and the unchecked arithmetic. In this case, however, the unchecked arithmetic actually can happen, and it's because the profit is multiplied by 95 divided by 100. So if the profit is really huge, the multiplication can overflow and can create undesirable revert. In other words, it can create denial of service. So it is already saying unchecked arithmetic operation detected, consider using check sub, check add, check multiplication, division, etc. Also saturating addition multiplication, that might be even better. Okay. There is another warning regarding the system variables. So you already know that if you want to use the clock, you don't need to specify clock as account, but what you can do is this thing. So instead of that, you don't need to specify clock as a parameter or as an account on the input, but you can use it directly at the runtime. And then yeah, this is just another unchecked arithmetic. Let me see. All right, these are all of the detectors in the project. However, we definitely have more of them. So let me have a look at the list. And maybe, yeah, so there is missing check command. That's definitely warning. Immutable account mutated. This is really interesting issue that we have experienced, that it already occurred multiple times in the reports. Basically, what can happen is that you have some kind of signer in the context of some instruction, and you do not mark it as mutable. If the account is not marked as mutable, the writability flag will not be propagated into the IDL. And what can happen is that if you transfer Lamport in the instruction to this account, or if you transfer Lamport from probably no, because there will be the sign requirement. So to this account, so for example, you want to close some data account and you want to return the rent into this account which is not marked as mutable, but is marked as a signer, what can happen is that in 99% of cases it will work because the signer will be transaction fee payer, and in that case mutable by default. But if there are multiple signers and in the 1% of cases this account, this signer is not transaction fee payer, in that case not mutable by default, in that case it will show error and cause potential denial of service. And what is the fix here? The fix might be pretty simple, however it might be also pretty complex, because it is just enough if you mark the account as writable in the IDL. On the other hand, if you propagated the IDL to different clients, different protocols, different users, bots, etc., you need to inform everyone that the IDL should be changed. So yeah, I think I think we covered most of the detectors. As I said, we are currently working on adding new detectors. We want to improve the already implemented detectors. For example, we are considering implementations and methods such as dial-in, etc. So we are definitely looking forward to the progress of the team. And yeah, that's everything from my side. Hopefully you enjoyed the presentation, and if you have any questions, I'm looking forward to them.
Absolutely. Andre, thanks so much for that presentation and kudos for the perseverance. I know you're feeling unwell, but the 270 odd people that are watching us live, I'm sure they appreciated you taking the time and going through all of that. So we have a couple of channels through which we received questions. Many people DM'd me, some came through Riverside, some were dropped directly under the post. Let me start with some of the questions that are asking us a little bit about the behind the scenes. And some people were curious, how does the extension actually detect the security issues under the hood? Is it using just static analysis, pattern matching, or something else?
Okay, good question. Yeah, we were definitely looking forward or trying to find the best approach. We were considering even AI and different stuff. For now, it is pretty simple. We just parse the source code and check for pattern matching. That's really that. So nothing really complex, I would say. You can try to implement it by yourself. The VS Code extension will be or is already open source, so you can try to implement your own detectors. We are definitely open to that. So yeah, pattern matching. But yeah, the approach is not that difficult, obviously, but to create really good pattern matching, to have not that much false positives and to have a lot of great detectors, that's where the magic is comes from.
Absolutely. Thanks so much, Andre. And this follow-up question is related to that, and it is, how do you decide which security issues to prioritize as detectors, and what is the process for adding new ones?
Yeah, so some of you may know that there is this library, or there are examples of C-level attacks. These C-level attacks are pretty nice, but we were definitely not focusing on them. However, I think I already mentioned this on during yeah, in the beginning. We were focusing on the experience. So as I said, we want to fill the gap. We are just doing static analysis. We will need to create really complex, difficult detectors. So we wanted to start with some, let's say, lower hanging fruits, maybe lows in informational severity issues, warnings, maybe mediums, and it was based on our experience. So we put our heads together. We discussed internally. All right, guys, there are some issues that are happening always in the almost always in the audits. So let's create something that people can use, and let's limit these warnings, info issues, lows, mediums, etc. So the short answer is basically experience in this case.
That's a good answer, and I think I'm very glad that you emphasized that because it's a key differentiator of our extension that it's built from actual people who are doing the Solana audits, who have the experience, who have found the criticals and highs, so that this is what we use to prioritize things. And moving on to the next question, it's actually from Solandi, and his handle on X is at Hey Andy S. And massive thanks once again for doing a video for the extension. His feedback is greatly appreciated. And he's asking us, does the extension support just Anchor or also native Rust, Solana slash program crate, or Pinocchio?
Really great question. So far, we are mainly in the Anchor, but in terms of support, there is no limitation for us to support also vanilla Solana, Pinocchio, etc. The limitation is just to create detectors for that. So yeah, you can install it, but it will most likely not detect anything in the vanilla Solana or in the Pinocchio. In the Anchor, yes. So the limitation right now are the detectors. So yeah, feel free to add detectors for the Pinocchio. It will be really, really great addition.
Perfect. And moving on from that question, somewhat related, one of our guests is asking, how does this fit into CI slash CD pipelines? Can teams integrate these checks into their automated testing workflows?
Okay, good question. Again, what you can do in the pipelines in the GitHub is that you can use Trident, the fuzzing framework. So you need to write the fuzz test, and we on the GitHub there are examples where we have pipelines. So you can use the pipeline for the fuzzer, but the VS Code extension it can be only used during the development process. You cannot use that in the GitHub pipeline or something like that. uh, just during development process. So you write the smart contract, you have installed the Solana extension, and when you press the Control Save and you save what you just did, you will see the in real time results of the detectors.
Perfect. Thank you so much. A couple of final questions as we're at time. One of them is because we have mentioned a couple of times the performance of the Trident SVM, and one of our viewers is asking, your app did 12,000 transactions per second under real blockchain conditions? Question mark. So let's address that question first.
The question was if we were able to do 12,000 of transactions in real blockchain conditions, right?
Yes, correct.
Okay, so we are not developing any kind of type of L1, all right, guys? So the Trident SVM, it is just the database over the Solana SVM API. So Solana SVM API allows you to basically process transactions without sending the transaction locally, without sending the transaction to any validator or to the cluster. So we have the Solana SVM API. We had to, we noticed the Solana SVM API. We had to implement a bunch of trade methods. We had to implement the database, which is a part of the Trident SVM. And this implementation allows us to process this number of transactions per second. But no, we are not doing any L1 or any different kind of stuff. So, or we are not even doing L2. This is just the, if you can remember, guys, there was this crate called program test in the Solana client. I think it was removed already, and we are doing basically something similar, but in a really minimalistic way in order to be performant.
Nice. Thanks so much, Andre. And final question, it's just about how to sequence things most effectively for building secure programs. And that is, do you recommend Trident fuzzing before VS Code static analysis or after?
Yeah. As I had the meme in the slides, I think everything has its own part in the workflow. And first thing that you should do at the start is to write clean code. So do clear folder management, write commands, etc. That's the beginning. Then write proper integration tests. Then yeah, at the same time use the VS Code extension, because as you write the smart contract, the VS Code extension can show you in real time detections. Then write really nice comprehensive integration tests, not just the happy paths, but all of the paths. Test the error values, test if the updates are correct, write invariants for them. And then if you have everything this, write the fast tests. and then continue with the audit. And that should be the correct workflow.
Perfect. So if I'm hearing you correctly, the correct starting point is join and graduate from School of Solana so that you can write secure Solana programs and then proceed as Andre just described. Okay, we're just 5 minutes past half past. Andre, thanks so much for this walkthrough. That was awesome. Nearly 300 people watched live during the session. So thanks a lot for the feedback. Thanks a lot for joining us. We remain open. If there is any feedback, drop us a direct message on at Trident Solana on X. We are looking forward to the feedback. And thank you once again, everyone. This would be the end of our live stream. Bye bye.
Bye, guys.